Hi and good afternoon. My name is Nurfatin Akila binti Azmi and my matrix number is 231302502. So today I would like to present about TinyOS. Before that, I will explain what is operating system. Well, operating system is a medium that acts as an interface between a hardware and a user. So next, what is a TinyOS? TinyOS actually stands for Tiny Operating System. It is basically combines Tiny with operating system. It is an open source operating system that is made with very little materials. Compared to other operating systems like Apple OS, Linux, and Windows OS, TinyOS is significantly smaller in size. Next, what is WSN? WSN is stand for Wireless Sensor Networks. This is a network of sensor nodes distributed in a space to detect changes and report the conclusions to a center-based station. Each sensor nodes are embedded with a tiny OS, which have low power, small size, and little energy. The many the many tiny OS attached with the sensor nodes create a network that collects information regarding the space. So what is the goals of tiny OS? One of the primary goals of tiny OS is to optimize energy usage in embedded system. It achieves this by allowing components to sleep when not in use, conserving power in resource-constrained devices that often rely on limited energy resource. Secondly, flexibility and modularity by using component-based architecture. TinyOS adopts a modular and component-based architecture, enabling developers to build applications by combining reusable software components. This promotes code reusability and simplifies the development and maintenance of applications for embedded systems. So thirdly, is a flexible framework for developing applications on resource-constrained devices. The operating system is written in the programming language NASC, a dialect of C that was created specifically for TinyOS to enable better support for its unique features and requirements. TinyOS is a popular operating system used in wireless sensor networks due to its efficient and lightweight design. So next, let's move into the example of TinyOS. There are various examples and applications of TinyOS in different industry today. For instance, is smart home. So TinyOS can be used in smart building application for monitoring and controlling energy consumption, lighting, heating, and ventilation system by collecting data from various sensors and actuators. TinyOS-based system can optimize energy usage, improve comfort, and enhance security in residential and commercial buildings. So this is the example of system architecture of smart home. There have been using so many sensors such as gas and smoke sensors, motion sensors, and temperature and humidity sensors. Next is the agriculture industry. Wireless sensor network using TinyOS can be deployed in agriculture field to monitor soil condition, crop growth, and environment factors. By providing real-time data, this system can help optimize irrigation, fertilization, and pest control, leading to increased productivity and more sustainable farming practices. So this is the example of the system architecture of agriculture industry. There have been using so many sensors such as soil ingredient sensor, soil moisture sensor, air humidity sensor, temperature sensor, and also ultraviolet sensor. Last but not least is how to enhance current TinyOS. Enhancing TinyOS can involve various aspects from improving its existing features to adding new capabilities. Here are some suggestions to enhance the current TinyOS. The first one is a real-time capabilities. Adding real-time capabilities to TinyOS may be beneficial for applications with strict timing requirement or that require advanced multitasking. This could involve implementing preemptive scheduling, priority-based task management, or other real-time features. The secondly is improve hardware support. Ensuring that TinyOS supports a wide range of hardware platform is crucial for its continued relevance. Developers may work on adding support for newer microcontrollers, radios, and peripherals, as well as improving compatibility with popular platforms like Arduino. The last one is the better integration with other IT platforms. Ensuring seamless integration with other IoT platforms and cloud services could make TinyOS-based devices more versatile and easier to incorporate into larger systems. This might involve creating libraries or middleware for connecting TinyOS devices to popular cloud service or IoT platform like AWS IoT or Google Cloud IoT. That's all from me. Thank you.